So in this video we're going to talk about the sine rule. This is mainly used for non-right angle triangles. If you have a right angle triangle, you can use the same rules as before with the SOHCAHTOA, but for this case we're going to use it for non-right angle triangles. So for any triangle, the sine rule is right here, where we have a over sine A equals to b over sine b equals to c over sine c. Just remember, when we're naming the sides and angles, so the angle is always the capital letters, and then the side is always to the, the side is opposite to the angle on the triangle. So if you want C, for example, C is always on the opposite side of the angle for C, and then if you want B, B is always on the opposite side of B. Now here's just a little example and showing you how you can figure out the sides and angles using the sine rule. I'm just going to do this mechanically first by writing out all the steps, and then afterwards I'll show you how you can use the E activity, which is a sine rule, so that you can actually do this on the E activity on your calculator. Okay, so we've got the triangle here. It's drawn. I've drawn it in, or I've copied it in, just to save some steps rather than having you wait for me to draw it out. So, we're given a full pair of b's, so that means we need to write out the ratio for b first, which is b over sine b, and then this says that we need to find out a first. With b over sine b equals to a over sine a, if we write out the values in here, b is 7. Now this is a small b, so make sure you write out the small b, not the angle. 7 over sine of 80 degrees equals to a, which is 4 over sine a. Now if you're having a little bit of trouble trying to solve it, I'm going to give you a suggestion. Cross multiply first. I'm going to firstly do this multiplication, which is 7 times sine of a. And then I'm going to multiply the next one to the right. So then we have 4 times sine of 80 degrees. Because we're trying to solve for a here, we need to put all the values onto the other side. There's a 7 here, so we're going to divide by 7 on both sides. So that cancels out. We have sine of a equals to 4 on 7 times sine of 80 degrees. So then we get a equals the sine inverse of 4 on 7 times sine of 80 degrees. So, firstly, I'm just going to put it in as what I put down before. So we have, we're going to put it down as we put down before. We have sine inverse of 4 divided by 7 times sine of 80 degrees. Make sure you close the brackets, make sure the brackets are correct, and then pressing execute will give us the answer 34.246. Just to also show you for E activity, if you actually click on E activity and then file, open, we have the sine rule here. Now yours might be in a different folder. I just put it in the default folder, that's why I can click straight into it. So just have a look at your folders before you do that. So sine rule, and obviously click are you sure, so okay. Now on the right here, there's actually an I button. What you need to do is you need to press that first. When you press the I button, you will notice that this will pop up with a separate section underneath. We're solving for a side that we're solving for an angle that we don't know, which is A, the big A. So I'm just going to click on that first. Whatever you click on, that's what it's going to solve. So we have A over sine A. A was 4. And then B was 7. the angle B was 80. Once we put everything in and you tap solve on the top left, we'll have the answer here of 34.246 as well. So from here on, I'm going to use e-activity just to do the rest of the calculations. Feel free to do some, actually, if I do the, okay, so continuing on, we need to find C now. Now, C, we're not told the small c, however we now have all the angles. We've got 34.246 degrees here. And so a triangle always adds up to 180 degrees. If we want to find C, then we simply need to subtract 34.246 degrees and also 80 degrees. Once we put that into the calculator, you should get 65.754 degrees. Alright, last step, we need to find the small c. So, same thing, we'll write out the ratio for b. So we have 7 over sine of 80 degrees equals to small c over sine of 65.754 degrees. If we multiply it on sine 65.754 degrees on both sides, you should see that you get C underneath here. Once you put this into the calculator, you should see that you'll get 6.48. Just to show you really quickly on the calculator again, we have A on sine A on this, but we don't have C on sine C. The way to counteract this problem is to just treat the C as A in this case. In other words, wherever you see small a, you're going to put down small c. If you see a big A, you need to put down big C. And so we know C, as in big C, is 65.754 degrees. So I put that in here. I've left the B's the same as before. And so when we solve it, we'll get A, which is 6.48. There we go. A is 6.48. So there is a special condition for sine. In when we use sine theta, so whatever the sine of an angle is the same as sine of 180 degrees minus that angle. So what that means is whenever we solve for sine, technically we actually have two answers. Now, we'll usually tell you what sign you need to look for. If it doesn't say anything, then this is the default answer. However, if we tell you to find both values, then you'll need to have one answer from here, and then the other answer from subtracting the two angles. So just a little example of this. I've saved a little bit of working out. We have two possible cases. So just to save a little bit of time working out, I've worked out what A is from the rearranging on the right hand side already. So for this example, we can have two different triangles because it's not stated which type of triangle you would have, because we're not told what B is. So we can have the two scenarios here. We can either have case 1, where A is an acute angle, so that's going to be smaller than 180, or case 2, where A is greater than 180. So what we need to do, you can use the e-activity to solve this if you like. I've already rearranged this to the right if you need it as well. If you do this, you should get 56.44 degrees. Now, this is only for case 1, because that's the acute angle. So we still need to find case 2, where it's 180 degrees subtracting 56.44 degrees. Once we subtract that, we should get 123.56 degrees. This would be for case 2. So there are 2 possible values of A. Alright, here's just a little example of an application question. You can read the line on the top. I'm not going to read through it. So we have 2 triangles here, where the first one goes from A to C to B like so, and the second triangle goes from C to B to D. So we know the C to B line is common between both the triangles, so we need to find this line first to do anything. Now, if you have a look at the angles, we've got 52 degrees here, 120 degrees here, so that means the remaining angle can be found with 180 degrees minus the 2. The reason why this one's a good one to do, to find out instead of all the other ones, is because if you look on the very bottom, we're told that that's 20 here. Because we know that that's 20, we then have a pair of sides to use the sine rule for. So we have 20 over sine of 8 degrees. Now we need to look for CB. CB is actually opposite to angle A, so we need to use sine of A. Just realized I made a little mistake here. Sine A should really say, oops, can't delete this anymore. Sine A should really say sine of 52 degrees. Once we solve that, then we've got 113.24. Last thing we need to do, we know that that's 113.24. This is a right angle triangle, and this is 60 degrees. That means we can actually use one of the rules that we already know from Sakatoa to actually find this. So this one's opposite the angle, that's the hypotenuse. So we then have sine of 60 degrees, giving us h over 113.24. Once we rearrange it, we should get 113.24 times sine of 60 degrees, which when we put it into the calculator, we should get 98.07. So just remember, for any of the application questions, I'll just write it down as a rule here. So I've just put it down as a rule on the bottom right. Always find a common side or angle between the triangles to do any of these application questions.